Rec is on.
Yeah. So I think we mostly talked about the star side. Where there's multiple hosts, all of them talking to the sky, right? It's a high level thing. I think the point we were talking about was really how do we do commands? Data pipeline, basically I think we already talked about like how do we just send periodically data, we'll come back to it if they have more this thing. The basic idea in here is you have a UI and on the UI there's buttons to do commands and the UI runs basically in the Sky platform. How does the UI send a command to things running inside the ZVM or the Z host? Right? As an example, there is StarNet and Stargate here. How does the UI send a command from here to a specific one? The basic thing that we had said was we only have an outbound connection here one way, which is based on HTTPS, or HTTP also is supported, but we don't use it. And the outbound connection is what is used to also for the UI to talk to this one, right? Because we don't open any firewall ports and we can't punch stuff in, basically need to do this handshake where we use this outbound connection to actually also receive stuff. And this is what we do using our request response, HTTP request response mechanism. And the way we do it is if we take a look at this HTTP. Usually in HTTP there is a server and client, right? And this is what, when you connect over HTTP, any enterprise machine sees. There is a client here and is doing HTTP or HTTPS. And if it happens to be there is a proxy in the middle that the enterprise has, we should work through the proxy also. To do this thing, what we do is we piggyback on the HTTP request to actually fetch our commands. And the way we do it is we send something called a command pole, which is wrapped in a HTTP request. Okay? And the response comes back as an HTTP response, and we get a command. This is an actual command to execute. So now effectively the server is holding on to this request for a long time to use this as a way to piggyback whenever there's an on-demand command from the Sky side UI. And then the reply to this command, we call it the command reply. Just so it's easier to talk, we don't call it response because response language gets confusing. The command reply goes in another HTTP request. Okay, and then there is a response at the end, which is just a dummy ACK.
So the first HTTP request, is it does the server holds the request for long duration?
Yeah, it's a long-lived request.
What's the time duration?
So I'll explain the higher level protocol. The time duration is set by the client and the server. So it's not done by the library level. But the basic request response mechanism is what the library implements, and on top of that, we're doing this higher level protocol. And the way we do it is.
So, is there a chance that if somebody is actually accessing some lot of things in UI, some commands will be delayed here because the poll is not yet ready?
Yep. So to do that, let's talk about the higher level protocol now, and then we can understand how we manage that process. Okay. So the way we do it is, Stargate has a module. We call it Star Commander, which runs as a part of Stargate, and this talks to Skygate. And within Skygate, there is a module called the Sky Commander. As of now, it's a one-to-one mapping, right? It just instantiates a module and then, you establish a pipeline to it. So these modules, the way it works is Star Commander is the one which periodically sends command polls. So it picks some n command polls that are issued outstanding. So this guy doesn't know about connections and HTTP and all. It's just, I'm going to send a command poll. Then there's a library layer which wraps it in HTTP request and send it to the other side. When the server receives these, And here again, they're unwrapped out of the thing. We'll talk about libcon in a minute, so that we'll see how that whole wrapping and unwrapping works. But the idea is that when the server receives these end command poles, he keeps them in a pole store.
It's some kind of a buffer.
It's a map. I mean, it's a slice of list of these things. And we'll talk about how the pole store is maintained also. There's interesting logic there to do. So these command poles go there. Now whenever he receives a command from here, look up, there is a command from the UI, right? Then you look up pole store and then use that to send a command here, actual command. And the moment the star commander receives a command, he immediately initiates a poll while it's processing.
Okay.
So we sort of keep that refreshed. And we also have a mechanism where, so one of the other things is HTTP, typically HTTP request timeout in 60 minutes. We don't time it out because we're doing our own HTTP logic. We're not relying on an HTTP library to do any timeouts. Because we just use a TCP socket and we send our own HTTP packet on top of it. Now we can keep it alive as long as we want. It's on a TCP packet that went out. But we could have intermediate proxies and all these things which could time out stuff, right? They look at something saying, hey, this request went out, I'm going to time this out.
Do you use a keep alive to keep that
Yeah.
session alive? Because otherwise, some intermediary firewalls and proxies might drop it.
Yeah. To handle that thing, what we do is we periodically time out these things here locally itself. We send command poles out, and every frequent time we sort of send new ones out. And within the command pole, in each command pole, we embed a timeout deadline or something, which sort of tells the library saying, okay, after this much amount of time, just drop it and send me another response back. So the library will, the client-side library here, does timeout any request that's handed to it to wrap it in HTTP and send it. So you might get timeout from the local library itself. So on the timeout also, we again send fresh command poles. So you always try to keep some n number of command poles always outstanding.
So the question is there no way for us to keep a persistent TCP connection which is, and do this rather than...
So the TCP connection is persistent. TCP connection is persistent. We're not disconnecting it at all.
Okay,
So actually the other thing is if the TCP connection ever disconnects,
right,
we detect it,
yeah,
we clean up all the existing poles, both sides, and when we establish a new connection, we immediately send another batch.
sure,
So we always keep it. But the HTTP part of it is different, right? Because when we do an HTTP request on top of it, we don't care to time out anything. We'll
Sure.
keep it alive as long as possible.
yeah, but
But once you introduce any firewalls and proxies in the middle, they have their own logic where they won't let a request sit there for too long. They'll assume it's some error and they'll respond to the client sometime with timeout, or they'll just drop the persistence. So if our server,
But
the
that
proxy
is because
sitting here,
of our choice of HTTP as the protocol, right?
Yeah.
If we were to implement our protocol over TCP itself,
yeah,
then this shouldn't be a
then it
problem.
won't get through proxies.
I see,
Because a lot of people block TCP traffic.
I see.
The whole point of choosing HTTP is to allow people to get it through the proxies.
Rather than have them configure their firewalls to let down
yeah.
traffic.
You will not get network teams to do that.
Okay,
So as long as it's trapped in HTTP, we can get away with most policies and everything.
I see.
That was the reason. So at this point, I think it's a good point at least talk about the libcon because you'll see it enough in all your, this was one of the larger libraries and it's does enough things which you have to know and to be able to debug sometimes when there's connectivity issues. So libcon, basically what it provides is you give it an address, it establishes a persistent TCP connection, okay, and then it provides interfaces to it. And the interfaces are byte stream, RPC calls, or even this RPC function calls obviously, and then the other thing is HTTP do. Okay. Now the way you can use this once you do create a libcon dot, and you can do both the same sort of thing, libcon dot client, and you can instantiate a libcon dot server, both sides. Okay. What this is taking is it creates a raw TCP socket And on top of that, it's doing explicit HTTP packet, like serialization and deserialization on its own. So it's not relying on the HTTP library to read write content. So now, if you
So
give,
this is so that you can package your stuff in the request and response as you need.
yeah.
Okay.
So for example, so if you give it a byte stream, so it gives you a channel, by the way, it gives you a channel of a byte stream. That's what it gives you.
Okay.
Or it gives you just a way to call libcon.rpc with a function name, like the standard RPC signature. To do, when you have a channel of this byte, you shove a HTTP
Serialized.
send request on it.
Okay.
And what that does is it takes a channel of byte and a deadline. When it takes a byte buffer and a deadline, right? You shove it on that one. Actually, so it's wrapped. This is a channel of a byte, but it's actually wrapped in a channel of HTTP send request. And this request is made up of the byte array and a deadline. Those are the two params it wants. And the deadline is that the client side now actually when it sends a request, it's maintaining its own timers. And whenever the timer expires, it will tell the client saying, hey, this request that you sent me timed out. And if that response comes back after the timeout, it just drops it on the floor.
So why do we do this rather than say make the command pool and commands just JSON and putting it in regular HTTP requests?
No, this is not a, no, what is inside this byte stream, this library doesn't care.
Okay.
This byte could be Marshall JSON. This can be Marshall protobuf.
Okay.
This could be string.
Okay.
String put into a byte stream, doesn't care. So the library itself doesn't care what is in this byte stream. Slice of bytes.
But when you send an HTTP request, instead of maintaining a raw TCP socket and executing HTTP ourselves, why don't we have like an HTTP server running and just write our protocol on top of HTTP? So like you will get this.
So there is a reason, because the way HTTP library works in Golang or any other library is this is sort of an HTTP library implementation, because standard HTTP library opens a lot of connections.
I see.
Which is a library configured parameter. We don't explicitly control it. So every time you do an HTTP.do, it opens the connections to the server. So if you do 10 requests, it will open 10 and then start reusing.
Okay.
It will also keep some of them alive, cache them, time them out. So it has its own control on how many connections it wants to use and keep them for how long and which request goes on which one.
Okay.
We basically don't want to have all of our machines, when we start doing HTTP request out to the R server, have tens of HTTP connections open from each machine.
Okay.
Because when the clients start looking at the network traffic and connections coming out of this, they'll see our whole cluster is swamping the proxy server with connections.
I see.
Right? So that's why we don't want to have too many TCP sockets open. From each star gate, star commander, just one.
Okay.
So the way the Stargate Star Commander module works also is Stargate has a connection, Star Commander just hands off byte streams to Stargate to send it out. So one TCP connection per host, that's it.
I see.
Okay.
Already with the number of hosts, that itself will start growing, but it's still one as opposed to 10 per host or 15 per host or whatever the thing.
Okay.
And in this one, so what we basically do is we take this byte stream.
Kiran, this timeout is how much?
No, this is the user sends it. In each HTTP, in each request, user can embed a deadline.
So the reason I'm asking is I have seen issues where from UI you send some request and it does not reach the server, the client side actually. So maybe this is why it has closed the client side already and.
No, let's talk about the library first, then let's talk about the higher level.
Okay.
The library doesn't care what you're doing. Library, if you give it a 0 deadline, I think it's infinite timeout. You just keep it there.
Okay.
So, or I think there's a standard default timeout, 5 seconds or 360 seconds. So library is just implement saying, okay, I'm going to open a TCP connection, give me an address, I'll do a TCP connection, and I'll talk HTTP, you don't have to deal with HTTP. So what the library implements is all HTTP passing. So it knows how to talk HTTP protocol, which is you put HTTP header first, followed by other headers, and followed by post body, and on the other side you read it, and it's a response, how to write HTTP response back. So basically this is a re-implementation sort of thing of the HTTP protocol.
Okay, 1.2.
Yeah.
HTTP 1.2. 1.2, right?
One.
Oh,
1 and 1.1.
nice.
But the headers haven't changed.
One question. So instead of single TCP connection, because in TCP, right, the window size gets calculated based on in between if there is sometimes many machines actually do MSS clamping to reduce the size so that fragmentation doesn't happen, right? So is it the optimum case that we use a single TCP connection? Can it be better performance wise if we use at least say 2, 3 like that?
Yeah. Yeah, we haven't done that study yet. One is, so for example, we might also want to say, oh, one we reserve for stats, where we're just pumping data upstream. The second one we keep for commands. Right? We could even do purpose-built sort of a thing. We haven't done that. We started off with one. We didn't want let the library control the connections. We want to control it. Now once we control it, we can start instantiating more. But that's an application level thing again. Saying, okay, I'll instantiate one libcon. I'll use it for some reason. I'll instantiate another libcon client. I'll use it for the other reason.
And in theory, we can also have a single Stargate serving a bunch of hosts. So you can do this multiplexing, trading of CPU and memory on the host as opposed to network.
Yeah. By the way, that happens now. One libcon server can actually service multiple libcon clients.
Yeah.
Right? It's the same. The code sort of looks very similar in how you use it. There is an accept loop followed by a serve. So you basically accept a connection and then start processing the packets out of it. So it's very similar looking code, just as a standard server code. But the one thing that you get to do.
Now the 4-node setup does exactly this.
Yeah.
One too many.
Another interesting thing to do is in the standard, if you use the standard RPC library out of Golang, you don't get this flexibility of doing everything on one socket. Because when you create a GOB connection, Golang RPC connection, it does the GOB protocol, which means both sides only speak RPC. So you can't mix any other stuff on the same thing because it starts looking for RPC headers right out of the bytes.
I see.
So this is one other advantage of using this connection. So you can actually do anything that you want. And the way this is done is in the library, depending on what type of input is coming through, it will actually put an extra header. There's an XRPC and X channel stream and sort of an X sequence ID header. And based on the header, the other side knows that, oh, this is an RPC, I should unmarshal the body as an RPC and do the call.